Hello, hello. The topic of today's lesson is finding missing angles in triangles. I'm going to label it like this, in triangles. So I call this chasing angles, chasing missing angles problems. And I hope you like them as much as I do, missing angles. Remember the symbol for angles. So we're going to try to find missing angles. First, how many angles are in a triangle? Three. Triangle stands for three. So let's take a look. A very simple experiment, a very simple proof. Let's call it proof. It's a very simple hands-on proof. If you take any generic triangle, nothing special about it, any generic triangle, and if you split it into three equal parts, let's call these parts A, part B, and part C, just like that. This is your part A, this is your part B, this is your part C. Split it into any parts. And line the vertices. This is going to be vertex A, vertex B, and vertex C. Line them up so they line up on a straight line, like that. Line them up on a straight line, just like that. You will realize that angle A will fit right here, angle C can fit right here, and angle B might fit right here. No matter which order you choose, all three angles will line up just so. Line up just so on a straight line. Notice, this is a straight line. And I hope you remember that last week, in last lesson, we learned that angles that line up on a straight line add up to 180 degrees. So if we have a straight line, and let's say we have two angles, right? Angle 1, angle 2, and angle 3 will add up to 180 degrees, right? This is our straight line S. This is our straight line S. So, in conclusion, all three angles in a triangle add up to 180 degrees. It doesn't matter what individual angle A and B and C is, altogether, angle A plus angle B plus angle C for any generic triangle will add up to 180 degrees. Let's use this information to start with basic exercises of finding unknown angles. Let's go. Measure and add up the angles of each triangle. I hope the measuring part you will do if you pause this video and use the protractor tool, which we practiced last week. I hope you realize that all three angles will add up to 180 degrees. I encourage you to use your protractor and measure all of these individual angles, and to prove the idea after you add them up, they should add up to 180 degrees. Notice triangles ABC look very different from each other, but the sum of all their angles is always 180 degrees. So what can we do about it? We have a triangle ABC. So we have a triangle A, B, and C. And the measure of angle CBA is 82, and this angle is 54. How do we find angle back? Not back, BCA. This is BCA right here, from B to C and to A, right? That's how we name the angles. How do we find this angle? Well, we find the missing part. In mathematics, in order to find the missing part, we use subtraction. We take away 82, we take away 54. And I will let you do the math independently because this math is quite simple. Now, exercise below, when we have this peachy looking triangle, peach colored triangles, is also of the same type. They're asking you to find missing angles in a triangle given two of the three angles. I hope you find this exercise quite straightforward because finding a missing angle is not that difficult. You just jump from your main idea that all angles add up to 180 degrees and you subtract 52 and you subtract 60. You can do it like that, right? And I hope we match and your angle A has 68 degrees, and the same thing for angle B. I hope our answers will match and you will get 102 degrees for angle B, right? We have a nice obtuse angle B, 102 degrees. And I hope after doing simple mathematics, our answers will match, and angle C for you will be equal 43 degrees. Remember, we take the starting point, right? The sum of all three angles is 180. You subtract the two angles you know in order to find the missing part. Now let's take a look at different triangles. Now we looked at generic triangles, but now what happens if we have a special triangle whose angle is 90 degrees? What if we have a special triangle with 90-degree angles? That, my friends, 90-degree angles right here, correct? 90-degree angle. And what happens if we have a 90-degree angle and the sum of all three angles? For example, we have a triangle again. We have a triangle ABC right here. And one of the angles is 90 degrees. That means that the sum of the other two angles also has to add up to 90 degrees. So what I mean by that is the sum of angles A and B has to be 90 degrees because 90 plus 90 gives us 180. And it's not that difficult to prove. Notice you can fold the triangle down the dotted line, and you know that both angles A and B will match exactly with angle C and be 90 degrees because 90 plus 90 gives you 180. So, similar exercise, we have a triangle PQR. We have a triangle PQR, and we know that one angle is 57. Another angle is labeled with this special symbol. We know it's 90. How do we find the missing angle R? We say 180. We can say 180 minus 57 and minus 90. We can do it that way. Or we know that if we have an angle of 180 degrees, that means the 90, pardon me. That means the sum of other two angles, Q and R, that means angle Q plus angle R has to be equal 90. So we can do simpler math. We can say, angle R equals 90 minus 57, which is, you're right, 33 degrees. So we can label this 33 degrees. So you can use the benchmark of 180 and subtract the two angles you know, or you can use the benchmark of 90 if you know there is a right angle of 90 degrees. So let's take a look at exercise number 6. Which of the following figures are right triangles? We're looking for right triangles. How can we prove if triangles A or B or C are right triangles? Well, we do know that all three of them will have angles add up to 180 degrees. We just need to figure out if the two of the known angles add up to 90. If these two angles that were given add up to 90, therefore, the remaining third angle will be 90. So let's go. 65 plus 25 equals 90 degrees. Therefore, it means the remaining unknown angle is also 90 degrees. Yes, this is the right triangle. Let's take a look at triangle B. Let's add up. 48 plus 43, the two known angles, that's 91. 91 is close, but that means the last remaining angle will be 89. And 89 does not mean we have a right triangle. It's a no. And let's consider angle C. 53, let's add up the two known angles plus 37 equals 90. If we have two angles that add up to 90, the third angle must be 90 degrees, and therefore, yes, we do have a right triangle. I hope you found this lesson useful. We're going to move on to